organized by which is organized by Jammu and Kashmir Economic Association Global South Research Foundation in collaboration with B.S. Badr, Rahman Crescent Institute of Science and Technology, Chennai, Crick University, Bangkok, Thailand, Deep Skills and Social Science and Humanities International. I'm Dr. Iram Sabha, Assistant Professor, Public Administration at Mangalaytan University. I'll be moderating this session. I would like to extend my heartfelt thanks to Dr. Firdaus Malik, Assistant Professor, University of People, USA, and President of Jammu and Kashmir Economic Association. I would like to thank Professor Habatullah Adam, Associate Dean and Founder and Director of the Jindal Center for Global South. Today is day 6 of the workshop, and the designated topic of the day is Advanced Applications of PLS Structural Equation Modeling. To deliberate about this session, we have a distinguished resource person with us, Dr. Jyoti Chahal. She is an Associate Professor of Commerce at Government College for Women in Gohana, India. With over 15 years of teaching experience, she holds a PhD in Commerce from Maharishi Dayanand University, India. And she also has dual master's degree in commerce and business management. Dr. Chahal has completed an Entrepreneur Edge course from London Business School, and her research interests include entrepreneurship, sustainability, consumer behavior, service quality, e-learning, and higher education. Her articles are published in leading international journals of Q1 like International Journal of Management Education, Management Decision, Journal of Computing in Higher Education, Skills and Work-Based Learning. She has also authored 1 book on entrepreneurship and edited 2 books. I welcome you, ma'am, to the workshop. And I request all the participants, please mute your mics for the smooth functioning of the session. Over to you, ma'am.
Thank you, Dr. Iram. Thank you very much for the introduction. And I'm delighted to be here with all of you today. And I'm also thankful to Dr. Firdaus Ahmed Malik for providing me this platform to enlighten my knowledge and sharing with all of you. And I appreciating the effort of Dr. Malik that he took initiative through this J&K Economics Association. I think this is a wonderful platform for our students or research scholars where they may get knowledge or experience for their research journey. So in today's session, I'll be taking you through some of the most advanced yet increasingly essential PLS SEM techniques used in high qualitative research today. And the goal of this session is very straightforward, like to understand how modern analytical tools like Gaussian Capula or NCA or SEPMA can strengthen our research and help us publish in better journals. So in today's session, I will teach you first about the concept and then discuss from the concerned research paper so that you are able to know how to report the results in your paper exactly and how to interpret them. And lastly, I will show it through some software, PLSM software. And so without wasting any time, so let's start. Let me share my screen first. Okay, is it visible?
Not yet, ma'am. Ma'am, your voice is breaking. I think you have a connectivity issue. Please check
Okay.
the connectivity.
Hello, Dr.
Screen is visible, ma'am, now. Ma'am, am I audible to you?
Is it visible
Yes,
to all?
PPT is visible now.
It's
Ma'am, ma'am, PPT is visible, but your voice
okay.
is breaking up. I think there's a technical problem with her PPT. Please bear with us.
Hello, dear participants. Our resource person is having connection issue.
Yes, Dr. Firdaus, yes, I'm back.
Yes, please go ahead.
Yes, yes. Let me share my PPT without wasting any time. Sorry for the disturbance. Okay, let me share my screen. Yes, is it visible now?
Not yet, ma'am.
Oh, okay,
Yes, now it is visible.
okay.
Mhm.
Okay, friends, let's discuss about some advanced technology of PLS SAM. And today in the session, I will explain about the Gaussian copula and CA-C-IPMA, right? So, in the era of this competition, you could say that PLSM has evolved. Reviewers and editors have become more, careful about the issues like endogeneity, model limitations, and practical relevancy. So the techniques that we are going to discuss today are designed exactly to address those concerns. So rather than looking at them as complex methods, I encourage you to think of them as helpful companions that makes your research more credible and more publishable. So let's start with our first techniques, that is Gaussian copula theory. Have you heard about any uh, issues regarding endogeneity or Gaussian copula? I think from this session, before this session, you have learned about the basics of PLSAMs like structural model assessment or measurement model assessment, moderation and mediation, all these things, right? So while targeting the high reputable journals, they always asking whether your model is free from the bias or not. Like, so here is a most important questions that you need to address before submitting your paper to the reputable journals. So the question is, are my results biased because something unobserved is affecting my model? So for this question, you need to target what is the endogeneity issue and how to resolve it or how to report this. So traditionally we use different kind of methods. You can say control variable approach, instrumental variable approach, latent instrumental variable approach. But today we are looking for the Gaussian copula. And the good news is that the smart PLS 4 makes the procedure extremely simple. You just select the relationship you want to check. Smart PLS creates the copula term and then you run the model again. So think of the Gaussian copula as a way of saying to reviewer that don't worry, my model is very clean and unbiased. So let's take a deep understanding of what is endogeneity issue. Look, here I frame one regression model where y represent the independent variable, and this model has two independent variable like x1 and x2, and they have a path coefficient of beta 1 and beta 2. And also we have some error terms and which is correlated and which is not correlated. Okay, so let me use here my pen so you can understand better. Okay, now what is endogeneity in this model? If we are looking like suppose in this model r square is equal to like 70%. Okay, and suppose q square is equal to 0. Say 45. Okay, so what does it mean that r square is 70% and q square is 0.45, then it means that your model has good explanatory power as well as predictive relevancy power is also good. But the r square is 70%, it means x1 and x2 both independent variable explain only 70% variation of y. So it means where is the 30%? So 30% may be from the another variable. Like, let me add, this is x3, another variable, and it has some impact on y also. So this x3, which should be the part of the this model, but we omitted this. We don't include this in this our model. So we omitted this to include this in our model. So this variable is called omitted variable. Omitted variable, right? So due to this omitted variable, it means your model is inconsistent and biased. Why? Because it may be happen that x1 is correlated with the error term of x3 variable. X3 means omitted variable. So in the perfect model, there is a situation when these independent variables should be independent, not correlated with the error term of omitted variable. But here it means if I could say this is error term, it should not be equal to 0. In that case, we don't have the issue of endogeneity. And this particular situation is called And this particular situation, it means when this is the situation where correlation is equal to 0, it means we have the exogenous process in our model. It means that is okay. But if the error term is related with the independent variable, that becomes the endogeneity matter. So overall, I would say that if in your model, the dependent variables are not purely dependent, they are correlated with the uh, error term. So in that case, you will find that your model is not robust and your model has the problem of endogeneity. So you have to correct it and you have to take it actions. Okay, so let me go through with the just a minute. I'm open the PLS SAM, so you could learn that how can we run the Gaussian copula for this matter. Let me share the PLS SAM screen. Sorry. Should be okay. Could you see the PLS SAM interface now?
Yes, ma'am, it is visible.
Okay, thank you. Okay, here sorry. Yes. Okay. Here I open one model where to save the time, I just connected all these things because I hope you all know how to develop the model or how to connect all these things. So in this model, look, I have endogenous variable that is bi, and second one is all independent variable that like I have 5 independent variable that is self-efficacy, effort expectancy, facilitating conditions, PE for performance expectancy, and social influence. Okay, and all these together have impact on the behavioral intentions of any technology, or you could say any new advanced interface or the system, right? So how to calculate the Gaussian capilla? How could I prove that my model is free from the endogeneity issue? So first of all, click on the I don't know what happened to my screen. It's not working. Yes. Now you can see when I click the Gaussian copula, it's now we can select. Okay, listen, in Gaussian copula, when you check the Gaussian copula result, what is the process? Like first you have to check the individual results, right? Like EFC, all these. And second one, you can you can check all these things in the combination of all these variables or in endogenous variables. So let's first check the, now I click, now I calculate. Let's have bootstrapping. In bootstrapping, the subsample should be 5,000 to 10,000. Here I'm using 5,000 to save our time. And I'm taking at two tail at 95% level. So let's start. Okay, now see the results. You could see that we have this like GCSE over BI. Okay, this was our the Gaussian copula result for the SE, and you could say that our in our case it is insignificant, and that is good. It means that our uh, correlation term is non-significant. It means this is good, and you can copy this all results to the Excel. Like I'm copying this, and I need only these things, so I just remove all these things. I hope my screen is visible to all of you.
Yes, ma'am, it is perfectly visible.
Okay, thank you. Okay, now next, go again. Now I'm going to target, like select, then just remove it because we have done this. Now again, we check for another, just for the sake of your understanding. Now again, calculate, start calculations. Go to the results, and here you could see that this is also insignificant. Insignificant means its p-value is less than 0.05. So it is insignificant, so it is good for us. And you can also copy this thing to the Excel that I did earlier. Now, again, select, just remove it. Now, again, I'm selecting for the combo of two variables. So click it. Now this click it. I'm looking for the combination of these two, SE and EE. So again, performing that same process, bootstrapping, go start calculation. and then, okay. So here my result, you could see GC for EE and GC for SE, that is 0.2232 and 0.713. Okay. So now the question is how to report this for sake of reporting all this output. So here I'm going to share one paper, research paper. Yes, this is the one research paper that is most important part. And this research paper is, sorry, this is the CIPA, it's a hair Gaussian copula. Yes, right. This paper is written by the Marco and et al. And this was come in 2019. And this paper actually deal with the model robustness in PLSM. So among them, one of the most important part is endogeneity. So look how they describe the endogeneity. Actually, they have this kind of model. They have a dependent variable of consumer intentions to purchase travels online. For that, they have three independent variable: trust, attitude, and communicability. So let's see how they address the endogeneity issue in this paper. And you have to report that your result in that way. Okay. Here's the results. Yes, this is the table, which is most important part, like assessment of endogeneity test using the Gaussian copula approach. So here they provided the result, like in first case they are using the Gaussian copula only on one attribute, like one variable, that is attitude, and they are reporting it is insignificant. The p-value is insignificant, so there is no issue of endogeneity. In second term, they are running it on the trust, then communicability, then in the combination of attitude and trust, and so on. And lastly, they collectively on all endogenous variables like attitude, trust, and communicability. So I hope you got the point. And now, after learning this Gaussian copula, you could definitely say to the reviewers that please don't worry, my model is clean and unbiased. So you may get confident about your model, and your chances of getting paper published is much high when you show that your model is free from the any unbiasedness or endogeneity issues. So I hope you understand this thing. So now moving towards my next topic, that is about the, let's see, NCA. NCA, dear friends, it is most important technology or the techniques, you would say, because in coming years, lots of researchers or lots of editors, they are uh, looking for the implications, implications on the basis of managerial implications, or what are the various theory you are making, or what are the concepts you are making. So definitely this necessary condition analysis is most important powerful tool where you can develop the theory. So it is in the area of business or in the area of management, or whether any kind of field, maybe in healthcare or policy research or in educations, the most of time we focus on what research or the what increases an outcome. But sometimes the question is very different. Here in NCA, we normally think about that, is there something without which the outcome can never happen? Are you getting my point? I'm saying that, is there something without which the outcome can never happen? And so this is the NCA finds. So it helpful to identify the minimum level of a conditions needed for the success. And this is highly and extremely helpful for the theory building. So it is also powerful tool for the policy recommendations. I'm giving here one example to you that like no matter how strong other factors are, if students don't have at least a moderate level of digital readiness, e-learning adoption cannot be take place. Could you see that e-learning could be adopted among the students if they don't have the moderate level of digital readiness? So we can find out the minimum level of a condition that would be required for successful of anything happening or anything outcome. Okay, so let's understand. In our cases, look, we have different kind of independent variable, but we want to find out that what are the various independent variable which is most important, like which one is our most important predictor or variable. For that purpose, we have different kind of techniques or different kind of ways. So among them, one of is path beta coefficient we can check in our multiple regression. We have also one technique that is importance performance map analysis, that is IPMA, where we can take the graphical representation of importance as well as mean score. And in modern technology, we have also artificial neural network. Okay, and last one is our necessary condition analysis. So basically, necessary condition analysis is developed by the DUL in 2016, and this techniques aims to reveal area in scatter plots of dependent and independent variable that may indicate the presence of a necessary condition. Okay, the necessary logic. And NC also determines a ceiling line on the top of the data. Now, you may ask me what is the ceiling line, or what are the various conditions you can sort out in the NCA. So in necessary conditions, in NCA, we have two kind of things. Number one, that is the condition that must have been, and it comes from the bottleneck. Later, I will show you from the software where you can easily. It seems very difficult here, but when you perform all these things on the software, it will be quite easy. So don't worry. Then second is sufficient condition. That means should have been. So in necessary condition, like example is usage is a necessary condition for any system to contribute to the success. But without usage, failure is definitely guaranteed. Okay. And in sufficient condition, we should be termed as that it should have been. Okay. It means that usage alone may not be sufficient for the success. Correct use and a change of the organization workflow in the line with system flows could also play a role in information system effectiveness. So in NCA, we focus on the necessary condition, that is must have been. So let's see what kind of ceiling line we will find out in our NCA. So there are two types of default ceiling lines. One is that is CEFDH. Okay, and CEFDH means the ceiling envelope meant free disposable hull. Normally we call it CE. Okay, that is ceiling. Just remember the name of ceiling envelope. And second one is CRFDH. It means ceiling regression free disposal hull. Okay, and the ceiling line, let me make it more simple to you so that you can understand it easily. Yes. Okay, I have taken this graph from the paper that is written by the Nicole and Etiol, and it is about the NCA. And this is the graph, most important graph. You could say the heart of the NCA. Okay, if you could understand this, you can apply the NCA very easily. So just try to uh, understand the funda of the NCA. So here we have some one dependent variable, and second one is independent variable. Here on x-axis we have independent variable, and on y-axis we have dependent variable. Okay, so let me take a pen. Okay. 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 Sorry. Okay. One thing is most important here, like suppose if we have independent variable and dependent variable and we have scatter plot over here, okay? These my points, okay? All these are my points, you can say. When I run the regression, then my simple regression line, this is dotted line. Got it? This is dotted line. It means OLS line. It is OLS line. It means ordinary least square line, a more simple regression line. It is. Okay. Then we have some broader points. We have some broader points which are beyond our regression line. So these are our broader points, right? These are our broader points. Okay. And when we run the regression line over these broader points, then our another regression line would be this red one. Okay, you can see this red one. Got it? And from this you could say the broader points, we can join this in a specific or in a spatial algorithm. We joined this in form of just an envelope, right? In form of just an envelope. So you could say in this line is become this in this zigzag form. So this zigzag form or in this envelope form, this is called the ceiling envelope free disposal hall line. Okay. And this is the regression line. This is called CR and this is called CE. Now, what does it mean? Like if I want to get my dependent variable, suppose I want 6. Okay. I want 6. Yeah, like this. Okay. So what kind of minimum level I should keep in my dependent variable? It means for attaining the level of y on 6, then I need to have 4.50. It means that is 4.50. Okay. And this is 6. So this point will be my over here. Okay. This point will be my over here. Draw it properly. Okay. And in this case, if I need y value for 8 or the level of y to the 8, then maximum units of x or maximum amount of x or maximum level of x, that means 6. Okay. So this, you could say this is and this is. Got it? So this is the logic behind this, and this is done by the bottleneck table, which is most important part for the NCA. Okay. Let me remove all these things. Okay. So I hope you understand the logic behind the bottleneck table. Now move to the next things that is most important. Another most important part apart from the bottleneck, that is ceiling accuracy. Another concept in the NCA that you have to know, that you have to disclose what is your ceiling accuracy. And what is the ceiling accuracy? It means ceiling accuracy represent the number of observation that you have are on or below. Okay, that is on or below the ceiling line divided by the total number of observation and multiply by the 100. And in ceiling accuracy, actually, there is no specific rule regarding the acceptable level of accuracy. But normally, we took 95%. We have to mention whether our ceiling accuracy is 95% or not. So rule saying nothing about it, or saying nothing, they are not specific about like how much it should be. But normally we reported that our ceiling accuracy should be above 95%. Okay. Then another concept is that is effect size and the significance of effect size. The effect size is denoted by the D, and it could be between the range of 0 to 1. And different parameters have been suggested by the Dull in 2016. In their paper, he suggested that for small effect, it would be among 0 to 0.1. And if your D is in the range of 0.1 to 0.3, it could be as a medium effect. Medium effect. And for the large effect, it could be your 0.3 to 0.5. And if your D or the effect size is more than 0.5, then it is called as large effect. And all these effect size, whether it is small effect or a medium effect or a large effect, you have to report in your paper. It is most important part of the NCA that you have to report your effect size, whether they are significant or not. If they are significant, then report the value of their level, small effect, medium effect, or large effect. Got it? Okay. Next is, okay, now it is most important part to understand in NCA what could be your element that need to be reported in your paper. I will calculate all these things and with the software, and I also show the a paper where you can understand how to report them. So first, uh, um, just remember the name of all these things that must be the part of your paper or your analysis. Like, so in the first, you have to show your effect size that I discussed earlier in the previous slide. Second, in ceiling accuracy, most of the cases we only show the CE, that is ceiling envelope, and then the permutation test, whether our effect size is significant or not. Then we have to run the permutation test. We have to report the bottleneck table also. And apart from that, sometimes reviewer asks you for the scatter plots or the graphs. You need to report all these kind of graph. Okay, and this is generated by the software. You don't worry. You are able just download all these graph, and you may consider these graph in your appendix of your paper. So scatter plot is very important, and bottleneck table is very important, right? So let's move to the paper first, then I'll show it on the here. This is, yes. Okay, this is the paper. This paper is actually again written by the Nicole and Etiol, and this is the paper of when predictors of outcomes are necessary. This is the guidelines for combined use of PLS SAM and NCA. Okay, so you have to report the advanced technology or the advanced methodology you are using. So sometimes researchers are using PLS SAM as well as NCA, the combination of both methodology, and you have to report that what are the results of PLS SAM and what results are of necessary condition analysis. So let's took a look about this paper, what they said about the NCA and all these things. Let me, yes. Okay. Yes. As I told you, that is developed by the NCA. NCA technology is first of all, it is developed by the Dell in 2016. Later on, various papers have come in the academia, and lots of new researchers or lots of existing researchers, they are experimenting on NCA and doing wonderful work about this technology or methodology. So, but basically, we follow the guidelines written by the Dell in 2016. And instead of analyzing the average relationship that we have done in, PLS SEM, NCA, what does NCA aims to reveal areas in scatter plot of dependent and independent that may indicate the presence of necessary condition. That is most important part. Okay. And we have also two regression line that I discussed already, the ceiling envelope line, which is a non-decreasing stepwise linear, and second one they are that is free disposable hull line, CER line, which is a simple regression through the CEFTH line. Okay. And another one most important, they have talking about the bottleneck tables, like where we learn that how much level we require to get a certain level of dependent variable. So they mentioned here that the ceiling line also indicate the minimum level of X that is required to obtain a certain level of Y. So, for example, X must have at least a level of 6. We have done it already, so I'm skipping all these things because in practical session we also doing these things. So let's another thing is here, that is, yes, this is that I discussed with you, the effect size. Okay, this is all the effect size. Okay, let's see the tables what they use. Okay, let's see the table. What kind of tables they are reporting, that is most important to understand, because in your paper you have to report all these tables in a particular way. Okay, so let's in end of the paper, I think, yes. Okay, yes, this is the most important table. Most of the researchers, they forget to explain this findings. There is a need to interpret the relevant findings of your NCA. You have to compare your findings with the PLS SAM result. This is the most important, and most of the researchers or any people who are just doing the PhD, and they are just forget like how to target the good journal, and editor just looking out for the comparative or the combined result of this, and for that purpose they are looking for this table, and if this is missing, you just cut your way. Okay, so for getting higher probability of getting your paper accepted, you must show this table. Okay, so here this table, I would like to explain this table so that it would be easy for you to calculate your points or the calculate your results. In this scenario, we have three kind of scenario over here, because in your paper you are using PLS SAM as well as NCA result. So what would be the interpretation of that result? So here I focus like if your exogenous construct is, suppose exogenous means independent variable. Okay. So suppose your independent variable like x1, if that is found to be significant in PLSM, as well as it is found to be a significant or a necessary condition according to your NCA result, then what does it mean? It means that on average, an increase in the exogenous construct that will increase the outcome, and however a certain level of like when we doing the bottleneck table, then you can understand that earlier I giving the example that y is your dependent variable and x is independent variable. For getting the level of 6, you have to be, or you should have the necessary condition of 8. Okay, so It means however a certain level of the exogenous construct is necessary for the outcome to manifest. In second scenario, if your exogenous construct is significant according to PLS SAM, but it might be happen that your NCA result, it seems that no necessary conditions. So in that case, what does it mean? That on average, an increase in the exogenous construct will increase the outcome. No minimum level of the construct is needed to ensure that the outcome will be manifest. Okay. And last one, when both methods show the insignificant. Okay, your PLSAM also saying that your suppose any independent variable is found to be insignificant, and as well as your NCA result show that this is not a necessary condition. So in that case, you might be conclude that a certain level of the exogenous construct is necessary for the outcome to be manifested. However, if further increase is not recommended, okay, as it will not increase the outcome of any further results. So this is the, I'm suggesting you, please, just consider this table. This is the heart of this NCA. And with the help of these results, you can develop the theory also. And editor always look for the development of theoretical framework. So you may use this and you should use this, okay? And another table, they reported about the NCA effect size. Okay, when we talking about the D, it is effect size. So in this paper, actually, they have two dependent variable. One is adoption intention, and second one is technology use. So for both endogenous variable, they have figured out the effect size and their p value, and this p value will come from the permutation test, right? So this is the PLSAM prediction. I think this is the normal thing that you have done earlier session, and this is confident. This is all about the PLSAM part. Okay, yes, that's an important part of the NCA. That is bottleneck table. Okay. So bottleneck table is most important. First, they have shown about the adoption intention, and second, they have shown about the bottleneck for the technology use. So this is their emotional value, easy of use, perceived usefulness, compatibility. All these are their exogenous variable, and for the endogenous variable of adoption intentions, and for the level of 0. Emotional value, not necessary. Easy of use, not necessary. Perceived usefulness, not necessary. As well as compatibility is also not necessary. Got it? But at the point of 50%, you require emotional value 25%, easy of use 20%, perceived use 9.3%, whereas compatibility is still missing here. There is no need of compatibility. And but the picture has changed from the 80%. All these things are required for the getting the adoption intention. So this is the bottleneck table and how to interpret the results I have been explaining. Okay. Now next, let's yes. So let's move to the NCA, right? Okay. I'm applying on the same file to show you how to run a NCA. So this is my model. Let me delete this copula first. My screen is visible or not?
Yes, ma'am, it is visible.
Okay. Actually, my connection is not good today, so I'm just doubting.
Now we are going smoothly.
Okay. Okay, this is our model, and here I'm going to run the necessary condition analysis, NCA. So let's start. So first of all, we will check whether our model is good or not, whether the validity, model validity is performing good or not. So for that purpose, we are just run PLS algorithm, and here I'm using Here you unstandardized and standardized. Here I'm using unstandardized. Sometimes by using the standardized latent variable scores, you got not good results. Like okay, but when you like sometimes it comes under the negative points. Okay, and that doesn't make sense when you calculate the bottleneck tables. So in that case, you have to use the unstandardized. Okay. Now default, keep it default. Now start calculation. Now just path coefficient. Okay, validity, construct reliability, validity. It's all good because all are in green. Now discriminate validity. It's all good. It's HTMT, and I hope you know what is HTMT, so I don't need to explain it again. HTMT from trait monotrait, it should be 0. It should be greater than 0.85. Sorry, less than 0.85. And this is Fornal Locker. It seems good. All diagonal values to the correspondings are higher. 8.96, 8. Yes, yes. Okay. All is good. Okay. Now what I'm going to, this is the latent variable score. Okay. I have to save all these scores. So for that purpose, PLS SAM's giving me the option to create a data file with these all scores. Earlier in the earlier software, earlier version of this software, they don't have the facility of this create data file. Just we have to manually download in the Excel and then save it and then again downloaded it. But in Smart PLS 4, it's quite easy. So now create data file. And here I just need only latent variable score. And this is the endogeneity. This is the name. I remove it. So I just keep it and CA demo. Okay. So now create, go back, again, save. Okay. Here you could say that we have NCA demo file, right? Data file, okay, with the latent score. Now click on the regression and give the name. Here I'm giving the name NCA again demo one. Okay. Save it. Okay. Now yes. I think this was our file. Okay. But it is not going to be smooth. Let me do it again. Yes, let me one more time. It's fitter and standardize. Now I have to find out the scores, latent variable scores. This is score. Now the create file. I need only latent variable. Create. Now go back. Again, go back. Now put regression. This is NCA2. Save it. Yes. Okay. Now this is your independent variable. Oh, sorry, dependent variable, intercept. Now select all these. I'm just putting the shift and arrow keys to select all these variable. Now just drag it. Okay, now this is our model, regression model, where we are going to perform the NCA. So now just put me in center to show it clearly. Okay, now calculate. Here we have option regression analysis, bootstrapping, logistic regression, NCA and NCA permutation. Regression analysis, just simply regression analysis which you may perform with the SPSS, but we are going to use the NCA, right? Here we recommend the number of step for 10 and just click on the start calculations, right? Okay. Now, what is the important thing here? Number one, if you remember the slides. Okay, let me open the slides. Okay, this is effect size, ceiling accuracy, permutation test, and bottleneck table, right? So look at the first. This is the effect size for CE, effect size for CR. CE means ceiling envelope, and this is CR, ceiling regression. And what is most important part is you have to report, that is most importantly ceiling envelope, and all these are the effect size. But whether they are significant or not, this is the part of another test that we are going to run in permutation. So that is also the important part. But here we are getting the effect size for the both ceiling lines. Okay. Now check the bottleneck table. Yes, this is the bottleneck table. We have three options: value, count, and percentile. Normally, we follow the percentile value. Okay, so here you could say that this is our dependent variable BI, and for different level of getting BI, we have some kind of values in their independent variable, right? Here in dependent variable. So for instance, at 10% of BI, we need to the level of EE, that is not necessary. 0 means it means NN, like you could say here NN, okay? And here you could say that in case of 90% of BI of any technology usage, you need a you need a 10.58 for the EE, FE 6.61, and PE 6.085, and all these things. So this is the most important part of your NCA. You have to report all these tables in your paper. Now, you could say the the NCA chart. If reviewers or the editor want to ask you about these chart that should be part of your paper, then you could download it from here. So all are given for the different variables. This is okay. So you can download it and just put in your paper according to the demand of your reviewer or the editor, right? Now come to the point of this effect size. Just I'm talking about that effect size should be tested whether they are significant or not significant. Then just go to back, calculate. Now this is the last option, NCA permutation. Click on this. Okay. Keep it 5,000 to 10,000. It's the demand of your paper as per the requirement, but I keep it 5,000 because of time saving, but you should keep it here 10,000. Okay, recommendation is for the 10,000. Significance level, this and all these, keep it as it is, then start calculation. Now see, now see. That is the most important results. Like we have different kind of effect size, but at the level of 95%, they are showing, some of them are significant, but FC and in case of self-efficacy, they are not significant because they are more than 0.05. So you have to report all these things. Got it? I hope you understand this uh, thing, and please go through the paper that I have recommended, and accordingly all these tables and all these, you have to report all these things. So this is about the NCA, and now moving toward the last techniques, that is our CIPMA, combined importance. Okay, let me save it. Yes. Okay, come back to our presentation. The next topic, the last topic is actually last topic is based on two methodology. One is IPMA and second one is NCA. That's why I consider first NCA, because it is also depend on the necessary condition analysis. So I hope you have already done about the IPMA. Have you learned about the IPMA before? Could you please give me any idea? Any one of student or participants can give me.
Any participant, whatever ma'am asking, please answer that.
No, ma'am.
No, ma'am.
Okay. So anyway, it's okay. Okay. In CIPMA, I suggest that is combined importance performance map analysis. So let me make it very, very easy to you, so you can very in effective way you can use it. And believe me, this is another important feature of your analysis. However, in PLS SAM, it is not, look, we have performed NCA, but there is no kind of such tool that you can use the CIPMA, because it is the combination of two methodology. One is IPMA and second part is NCA. You have to combine both of them technology, right? And then create the necessary recommendations or the implications. And CIPMA is very important analysis, because we often talk about the importance performance analysis, and separately about the necessity that we have done just before. So CIPMA allows us to bring them together. And friends, this technology, this methodology helps us to answer some very, very practical questions, like which factors matter the most, which one are important, which are performing very poorly, which ones are absolutely necessary, and what should managers or policymakers focus on first. So CIPMA give us a very comprehensive picture, or you can say the perfect for the real world implications, right? So in various area of the research, like technology adoption or the consumer behavior or sustainability, climate change, customer loyalty, service quality, in all these recent or
Ma'am, I think you have muted yourself.
editors or the researcher.
Excuse me,
Sorry.
ma'am.
Mm-hmm.
You were not audible for some time. Please, could you repeat these lines?
Okay.
Yeah, thank you.
I'm saying that the combined I'm saying that combined importance performance map analysis is a combination of two technology. One is importance performance map analysis, and second one is NCA. Are you getting my point? Am I audible perfectly or not?
Yes, yes, now you are audible.
Okay. So I'm just saying that this methodology is very, very useful to analyze some questions like which factors matter the most, which ones are performing poorly, which ones are absolutely necessary, and what should managers or policymakers focus on first. First, it means what should be their prioritizations, right? Better management action prioritization, you could described in through the CIPMA, right? So overall, I would say that combined IPMA or the CIPMA gives us a very comprehensive picture or a perfect picture for giving the real world implications. Okay, and these implications could be given in various research areas. It could be the technology adoption, it could be the consumer behavior, sustainability, climate change, customer loyalty, all these things. So it is very important technology because see, IPMA give you a managerial implications, and your paper could be very useful for the other researchers. You are giving a most important insights to this tools. Okay, and this tool is again combination of two, that is IPMA and NCA. And in PLS SAM, there is no option for performing the CIPMA. You have to perform differently and you have to make some calculation for this. So let me first share the paper, what kind of things we have to report, then I'll show it practically on the software. Okay. So let me open the paper. Yes, this is okay. Yeah. This is the last paper that I have that I'm going to discuss about it. This is the paper of Marco and Etiol, Marco, Nicole, Seven, and Christian. And this is about the combined importance performance map analysis. This is open access paper and you can download it on the website of the journal as well as on ResearchGate sites. You can download it. Okay. Okay, now this paper is very wonderful. Why? Because this paper is totally based on, they just give the screenshot of every steps. So everybody can learn it from this paper very easily because all steps are given in the screenshot based, right? Whatever the steps are given in the software, they are just putting in the form of screenshot. Okay. So let's discuss first this paper, then come to the PLS SAM. Okay. Have you got idea right now? Are you able to understand what is exactly the CIPMA? Okay. Here, actually, here we have two things. One is IPMA. In IPMA, we will conclude about the importance, and second one is performance. Okay. Let me give you the idea first. Okay. According to this paper, you have to show your results in the form of this table, right? So in this table, you have to report about the importance. And what is importance? Importance means the total effect. Normally, we take the total effect or the path coefficient. But if you have any mediation in your model, then you will consider the total effect. But if you have no mediators or no any other thing, only direct relationship in your model, then you will consider the simple path or the direct effect. But normally we consider the total effect. Second one, we will take about the performance, and performance means the mean performance. Okay, and then we have to report the screen plot where comes from the bottleneck chart from the NCA. We also actually these 2 points are, let me make it clear to you. These 2 points are related to IPMA. Okay, importance performance map analysis. And these 3 points are related to NCA, right? That is bottleneck chart, NCA permutation, and bottleneck table, right? So with the combination of these two things, IPMA results and NCA results, you will create a combined IPMA results, right? Okay. Now, after getting the result from the previous table, from this table, now it is most important part to interpret your results. I have taken this screenshot from that paper also. You could see from that paper, and please explore and check that paper. That is very important paper for to understand the CIPMA. So the logic I'm explaining here because time is running out. So logic of this CIPMA, let's see that I have explained that this tool is very perfect for explaining the real world implication. You could say the practical implication of your paper or your work. Like, so in performance importance map, we have on x-axis, we have importance, y-axis, we have performance, right? And we have four part of this graph, like performance is low to high, but importance is low to high. Okay. So in this first part, if necessary level given is NCA bottleneck table, if there are two things, okay. So if this in this part, let me in this part where the performance is high, let me write high, okay, but the importance is low. So in that case, that is the satisfy, just take along. Okay, that is the most important part. That is the decision or the managerial implication. In second case, where the performance is also low and the importance is also low, that is very poor thing. Okay, so that is put low priority here. You are not doing good in these things, so just put low priority here. Okay. Third one is that is where the performance is very high and your importance is also high. So this is the good situation. Okay. So business or any other sort of organization, they want to keep the good work and maintain. So here the strategy would be to sustain that performance, right? And in the last zone, you could say the performance is that is low and importance is high. This is the crux of the paper. It means you have to prioritize this zone. It means concentrate here and improve your performance also. Okay? Because importance that would be your any independent variable. For instance, for adoption intentions of artificial intelligence, would say. It requires the readiness of the consumer. Okay, that is most important factor after getting the analysis. So in that case, it should be prioritized. It should be concentrate and improve here. Got it? So let's come back to the paper. Okay, they have this kind of model here. They have adoption intention, technology use, then they have emotional value, easy of use, and usefulness and compatibility. These are the four their independent variable and exogenous variable. So first of all, in IPMA, let's just their tables, what they are explaining. Okay, NCA. Yeah, this is what the important thing. And say you already learned what kind of results they are. Again, they are discussing the same things, so I don't need to explain again. So what is the important things over here? That is the combined IPMA or the C IPMA results are more important here. So you have to perform this table. You have to draw this table or complete this table and report this table. So that is your all variables, their importance, their performance. I will show you how to calculate all these things because software will generate for you, but you just need to put the right way in your table. And this is the part of IPMA, importance and performance, and this is the part of your necessary conditions. I mean the part of NCA, these two things, NCA, and this is the effect size that we have already done it along with their significant or not, whether they are significant or not. We will done it through the permutation, if you remember. Okay, so this is the most important table. And another one, this is the most important chart. Chart is the same, but here the author recommended the bubble chart. So after using the bubble chart, so here the higher bubble shows the higher prioritization. So you have to, okay, report whether which one should be the prioritized, which should be the ignore, okay, or avoided, right? So that's all these things or nothing. All these are screenshots of the um, okay, let me explain it on to. Okay, are you able to see the PLS SAM software interface? Right? This is again, I'm performing first. This is the model. So let's first start calculate, then go to IPMA, that is importance performance map analysis. Here, remember one thing, importance is different thing and performance is different things. Okay. So when you click on the IPMA, the software will ask you which construct. So here only we have one dependent variable, that is BI. Then they are asking the all predecessor of the select target construct or direct, because we have direct. So normally we have all. Okay. Now keep it the same. They just showing your maximum, minimum scale, all these things. Now the start calculate. Okay. Now what do you need to report in your paper, or what do you save from this software? So first of all, see the total effect. You will take this figure, total effect. Let me copy it to the Excel. Hmm, okay. So here I'm writing importance. Okay, here I'm writing performance, right? Okay. Don't need to take BI because it is endogenous variable. Cut all these things. This is your, okay, and this is your, okay. Now go back to the results. Now that is our performance, right? This is our performance. So again, this is copy. And just select all these things. And put it in here, paste, right? This is simple IPMA, okay? However, you can here the results has been shown in the, okay. This is the map generated by the software. So you can use it, but you can use it in only IPMA, not in combined IPMA. Okay, in combined IPMA, you have to create your results, right? So this is the simple importance performance map. So you could prepare it in Excel too. So what does it mean? Here, just try to understand it. Like here is SCI. Okay, SCI has the most important part. Social influence has the most influential factor or the most important factor for the BI. Okay, because it has the high effects. Okay, whereas that is PE. Yes, that is SE, FC, and ER. They are all the like, almost same low performance, right? Next, just calculate, or we can create, this is from the chart. This is, let me create, insert, scatter plot. Okay, got it. Okay, this is C IPMA, right? You may give the name. So data labels, then select more option. From the cells, cell this one, select. Okay, you don't need to show this value. Okay, so this is your simple plot of the sorry, it's not a C IPMA, it's only IPMA. Sorry, it's only IPMA. Okay. The next step, we will do the NCA because we have to combine the IPMA results with NCA, and then we will create. And for saving the time, I have already done all these things. So you could let me share with you. This is the results. I hope NCA is already done by you. So here the same results, I think in our previous, yeah, the same result, the same file that I have used. And then I calculate the necessary, the earlier. Okay. In that case, we have this effect size and their permutation value, you could say. Okay. And then you could say, let me just a minute. Put it here. And this is the bottleneck table. I hope I do not need to again run the NCA because we have already run that. But you have to know what is the bottleneck table and what are the results. So this is the bottleneck table, and we take a certain level of bottleneck table. Okay, so like we have here this. Let me bold it. Okay. Okay. So now the process is when we performing IPMA, then we have to report or we have to calculate the importance. That means your total effect, then the mean average score that is given by the software in under the heading of performance. Now, after performing the NCA, we have to use two tables. One is bottleneck and another one is effect size. Okay, the significance of effect size, right? So now creating the this table, that one section is also should be here, that is necessary. So here the rule is just see the element see the variable that is EE, whether it is necessary or not necessary, just go through these two tables. Okay, like EE. EE is, yes, it is necessary and it is the effect size is also significant. So how much it necessary? So it is 10.582 at the 80% level. So I just keep this value in this table over here, right? And then see the FC. FC, let's move to the FC. FC is insignificant. Okay, there is no need of the facilitating condition in our model as a necessary condition. So we will keep it here 1 rather than the value of bottleneck table because its effect size was found to be insignificant. So then we will keep it 1, right? Got it? Another one is PE from the first PE. It is significant, effect size was significant, and then check the its bottleneck level. Okay, then it is 6.085. Then we mention over here 6.085. So in this manner, you can putting your values in the section of necessity or the necessary. So while combining all these factors, you can create a bubble chart. Okay, let me, that is create a bubble chart, a simple bubble chart. Okay, so this will be the bubble chart. This is already I have created. This is the same thing, but to saving our time, I'm just removing it to show you clearly. So this was your bubble chart for the simple IPMA. Let me put it down here, IPMA. You make a comparison. Okay, this was your simple IPMA map, and this was your combined IPMA. Combined IPMA, it means there is a combination of IPMA as well as your NCA results, right? So this is the difference between the simple IPMA and the combined IPMA. And combined IPMA is the most important part to create a managerial implication or the real world implication. So here you could say that the size of the bubbles are relevant. Bigger size, it means there is a relevancy, there is a need to be target, make it prioritized, and there is need to be worked out on. And the smaller size, it means they are not necessary and they should not be given any priority. So that's all about the technical thing. So in case of publication perspective, I just want to highlight one important point here that these tools are not just analytical choices. So they are strategic choices for the publications. And you know, one thing that the top journals, like whether it's a Journal of Marketing Research, MIS Quarterly, or the Journal of Academy of Marketing Science, okay, all top reputed journals today, they expect that endogeneity checks, they expect novel analytical insights, they expect strong theoretical justification, they expect a clear practical implication. So using Gaussian copula, NCA, CIPMA naturally positions your work as a modern, rigorous, and impactful. So to conclude my session, let me summarize all things that I want you to take away. That is Gaussian copula, ensure your model is reliable and unbiased. And NCA will tell you what is absolutely essential for an outcome. And combined IPMA helps combine sufficiency, necessity, and performance for strong recommendation. So Smart PLS has made all these tools user friendly. So our job is simply to use them wisely and interpret them thoughtfully. And for your success, I again recommend then please read out all these recommended paper. They are very, very helpful. So this is from my side. And let me stop sharing and I'm open to your questions.
Thank you so much, ma'am, for insightful session and how beautifully you deliberate about the Gaussian Coppola NCA or CIPMA. So thank you so much. Now I would like to open the floor for question answer. Participants, if you have any question answer related to the session, please go ahead.
Uh, Ma'am, good evening, ma'am.
Good evening.
Ma'am, my question is about the software, ma'am. Actually,
Yes.
I am new. This is new for me. So
Okay.
I want to ask about the question like is it used for quantitative research or qualitative research? Ma'am?
It is definitely for the quantitative research, not qualitative. For qualitative, we have lots of other software, whether it is Orange and Vivo. Okay. So this
Yes,
software, PLS SAM software, is entirely for the qualitative research. Sorry, quantitative
oh,
research. Yes.
quantitative research. Okay,
Yeah,
ma'am.
quantitative. Yes. Because in
Ma'am,
today's session, we have done all quantitative things, na?
yes,
Only
ma'am.
quantitative. So this is all about quantitative work.
Okay, ma'am. Thank you, ma'am.
Thank you.
Any other question?
Ma'am, I want to request you to please, in 2-3 lines, you explain the D value. You have
Okay.
the range of D that is between 0 and 1. If you please explain it again.
Yes, I will explain and I will share you the paper with you and you can let me here open this paper if they have the okay. D value is basically about the effect size. Okay, effect size of your permutations. When you performing the NCA and NCA in your exogenous variable or your independent variable, they are showing their effect size, and that is denoted by D. Okay, and if this D fall in the value of 0.025, then it becomes your different kind of range. Okay, so it is D is from the 0 to the 1. So like if it is between the range of 0 to 0.1, so it means your exogenous variable have very small effect in the contribution of your dependent variable. And it if it is under the rate under the limit of 0.1 to 0.3, it means greater than 0.1 but less than 0.3. Okay, less than and equal to 0.3, then it become as a small sorry, as a medium effect. And if it is large, if it is in the within the range of 0.3, greater than 0.3 and less than 0.5, then it is large. And if it is greater than 0.5, then it become large effect size, most very large effect size. Got it?
Okay, any other question?
I just recommend to all participants that please and please practice on the software. Until or unless you never practice, you can't be able to learn all these things because it's all practice based.
Yes, ma'am.
Okay, ma'am.
So let me share the screen and share the gratitude of appreciation to our resource person and moderator.
Thank you.
Thank you so much.
So you can conclude now, Dr.
Okay, I would like to thank our resource person, Dr. Jyoti Chahal, for a insightful session and how detailedly she has discussed about the different concepts in PLS SEM. And I would also thank Dr. Firdos for giving the opportunity to moderate this session and all the participants for their patience and sanity. Thank you so much.
Thank
And
you.
Dear participants, if you are able to on your camera, quickly on your camera. We are already late. Dr. Jyoti, are you able to on your camera? You are not there on screen.
Okay.
Okay, dear participants, there is too much noise in my background, so I would like to conclude the session now. So regarding the certificate, some people have write down only their post name. So as I have told you, once I will add your details in the software. The way you are writing the name, it will be your error. So I will not be correcting that. So I will give you one more chance. If somebody has write down only first name and want to full name in the certificate, kindly you can fill that Google form again. Okay, till the last session, do fill your correct information. Then if there is error, so I think I will be helpless to help you. So thank you very much. But again, neither you are liking our videos on YouTube. There is no like on the recordings. So I do not know whether it is asking you to pay for that to like. So as you are using all social media, you can make one like to each recording session. You can put your comments. You can give your feedback there. How was the session and all. So I
Sir,
appreciate if you will be able to. Yes.
sir, where you will send the Google form in the WhatsApp group?
Yes, on the WhatsApp group. You are on WhatsApp group.
Yes.
Okay, I will be resharing you for you all. So just look into that, fill it, but fill it carefully. So okay, I think there is
Particular
less.
information you have sought, that is our name, institutions, affiliation,
Yes, somebody
designation, and
has.
all
Yeah.
that we have actually separate.
There are few errors. For example, there is university name. Some are writing GII.
No.
So I cannot be helpful then.
Cool, we
Some
have
are
written.
writing short form. Some are writing like MET University. So there
Oh,
are thousands of MET University. So that is why I have created this Google form to facilitate you. So there were so many mistakes also in the registration form. So take it serious. So this was
Okay, sir.
all from my side. I would like to pay thanks to Dr. Jyoti Chahal and Dr. Iram Sabha for sharing their insights about PLS SEM. It was the sixth day today, so where we have learned really interesting and technical tools about PLSM, how we can advance our publications and all, and for accepting for accepting our invitation to share your insights in our workshop. So I am
Thank
thankful to both the resource person and moderator on behalf of Jammu and Kashmir. So we would be looking forward for more such collaborations. Thank you all. If you are having any questions, you can reach me on WhatsApp. You can inbox me. Okay. So now we are concluding as this was the one of the
Sir,
longest.
tomorrow's session time.
Resource person is yet to get connected. If he will, show up, I
Okay.
will be, sharing you. So I didn't get connected with the resource person. If he will agree, so then most probably it can be from 10:30 a.m. Yeah, from 10:30 a.m. tomorrow. After that, we can have a good weekend. Let us see.
Okay.
So I am now
Thank
closing the session. Okay.